The nearest star is not close. That sounds wrong at first, because we have been trained to hear the word nearest and relax. Nearest sounds friendly. It sounds like the next house, the next town, the next place you could reach if only you built a better machine. But that is exactly where the mind makes its first mistake. Proxima Centauri is about 4.24 light-years away, and the dangerous word in that sentence is not light years. It is about. It makes the number feel small, rounded, manageable. 4.24. You can say it in one breath. You can put it on a screen. You can make it look clean. But the universe is not clean because our language is clean. A light year is the distance light travels in a full year, and light is not slow. Light crosses the distance from Earth to the Moon in a little more than 1 second. It reaches us from the Sun in about 8 minutes. And even light needs more than 4 years to reach Proxima. So, before we imagine astronauts, engines, flags, footprints, or some brave human voice speaking under another star, we have to slow down and say the less exciting thing first. Proxima Centauri is not really a destination yet. It is a measuring stick laid across our present limits. I do not say that to kill the dream. I say it because a dream that survives measurement is stronger than a dream that avoids measurement. Science does not begin by decorating the universe with wishes. It begins by asking what is actually there. How far? How fast? How much energy? How much mass? How much danger? Then, after that, we can ask, what kind of ambition is still left standing? And with Proxima, the first thing left standing is not a spaceship. It is distance. A stubborn, cold, almost rude distance. The kind of distance that does not care that it is the nearest star. Nearest only means less far than the others. It does not mean near in the human sense. It does not mean reachable. It does not mean next stop. That little word tricks us, because on Earth, nearest usually means practical. Nearest hospital. Nearest station. Nearest town. In astronomy, nearest may still mean almost impossible. The closest fence may still be a wall, and in this case the wall is 4.24 light-years wide. Let me put the number in a way that the body can feel, or at least try to feel. A light-year is not time. It is distance. It is what happens when light moves for 1 second. Then another second. Then a whole day. Then a whole year. Now multiply that by a little more than 4. And you get nearly 40 trillion kilometers. 40 trillion. That is one of those numbers the mouth can pronounce while the imagination quietly gives up. We can picture a room, because we have crossed rooms. We can picture a city because roads and cars have trained us to believe in that scale. We can even picture the moon a little, because it hangs there in the sky, bright enough to feel like a place. But Proxima does not give the senses anything useful. You do not see it with the naked eye. You do not feel its presence. You do not look up and say, there is the next shore. It becomes real only when we translate it into delay, speed, energy, and mission time. Start with communication, because that is the easiest traveler we have. A radio signal moves at light speed. It has no crew to feed, no bones to protect, no fear to manage. Send a signal to the moon, and the delay is a little more than 1 second. That is almost a conversation. Send one to Mars, and now you wait minutes, depending on where the planets are. Annoying, yes, but still something a mission team can live with. Send one to Proxima, and the message takes more than 4 years just to arrive. Then, if anything answers, you wait more than 4 years again. That is not remote control. That is not normal exploration. That is writing a question into the future and receiving the answer from the past. Already, before we move even 1 kilogram of metal, the nearest star has changed what contact means. Now put a spacecraft into the story. Not a magical one. Just a machine made of instruments, wires, shielding, fuel, memory, software, and parts that can fail. We have built magnificent machines. We should not pretend otherwise. The probes that have left the planetary region are among the most astonishing things humans have ever made. Little organized pieces of matter escaping the sun's neighborhood. But compared with Proxima, they are slow. Painfully slow. At the speeds of our present deep space probes, the trip would take tens of thousands of years. Not a long career. Not a difficult expedition. Not even a story 1 generation can hold in its hands. Tens of thousands of years is enough time for languages to disappear. Coastlines to shift. Nations to become footnotes. And the builders of the spacecraft to become ancient people in a museum of memory. So when someone asks why we have not gone to the nearest star, I do not think the first answer is courage. Courage matters. Of course it matters. But a rocket does not move because the crew is brave. Curiosity matters too. But curiosity is not velocity. The machine moves because momentum is conserved. Because energy is supplied. Because something is pushed backward or pushed by some outside force. Nature keeps the books whether we like the numbers or not. And interstellar travel runs up the bill in every column at once. Go faster. And you need more energy. Add shielding. And you add mass. Add mass. And the engine has a harder job. Add a crew. And now the spacecraft must carry air, water, food, radiation protection, repair systems, medicine, and time itself as cargo. Every solution becomes weight, and every bit of weight asks the engine another question. That is why I hesitate to call Proxima a destination. I understand the word. I understand why people use it. It is the nearest star, so the mind wants to draw a line and say, there. But a destination is stricter than a dot on a map. To arrive, you need control. You need to slow down. Look around. Keep the spacecraft alive. Gather knowledge. And send that knowledge back. If you fly through a star system at a huge fraction of light speed and cannot brake, you have crossed the distance. Yes, but you have not arrived in the ordinary sense. You have made a flyby. Maybe a beautiful one. Maybe a historic one. But still a flyby. Arrival means the velocity has been tamed. And that is a much harder sentence than it first appears. And when we try to shorten the travel time by going faster, the empty space between stars stops being harmless. Empty is not perfectly empty. There are atoms out there, charged particles, grains of dust, tiny bits of matter drifting in the dark. At ordinary speeds, a dust grain is almost nothing. At 10% of light speed, or 20%, it begins to look less like dust and more like a bullet made by physics itself. The faster you go, the more dangerous emptiness becomes. That is not poetry. It is kinetic energy doing its plain work. Then add the human body, and the problem becomes even less romantic. A probe can be cold and patient. A human cannot. A person breathes, sleeps, loses bone, needs water, needs air, needs protection from radiation, needs a mind that does not break inside a closed metal world. Take the body away from Earth, and engineering has to replace the planet. So Proxima is a fair teacher because it is not some absurdly distant target chosen to make us feel small. It is the first star beyond the sun, the nearest one. And that is exactly why it is so unforgiving. If even this star demands speeds we do not yet command, energies we cannot yet manage, shielding we cannot yet build at the needed scale, and mission durations longer than normal human planning can comfortably hold, then the problem is not that we picked the wrong star. The problem is that stars belong to a scale our civilization has only begun to measure. That, to me, is the real beginning of the story. Not escape, not fantasy, not a red dot waiting politely for us. The beginning is a correction. The closest star is not close. Once we accept that, the question becomes better. Not when do we go, but what must become true before going has physical meaning. What must change in propulsion, energy, materials, autonomy, shielding, and human endurance. For now, Proxima Centauri is a ruler laid across the darkness, one end touching Earth, the other touching the nearest star. Along that ruler we can read ourselves clearly, our speed, our fragile bodies, our unfinished machines, and our habit of making distance sound smaller than it is. That humility is not the end of exploration. It is where serious exploration begins. Now let's slow down and ask a very plain question. What is Proxima Centauri actually like? Not as a name on a star chart, not as a romantic target for some future spacecraft, but as a real physical object sitting at the other end of that enormous distance. Because the word nearest can fool us. It makes the star feel almost familiar, almost reachable, as if the universe has placed one friendly lamp just outside the door. But that is not what Proxima is. Proxima Centauri is not the sun's little cousin in any simple sense. It is not a smaller yellow sun turned down gently like a dimmer switch. It is a red dwarf, and once you say that carefully, the whole picture changes. A red dwarf is small, faint, cool compared with the sun, and incredibly long-lived. Proxima has only a small fraction of the sun's mass. Roughly the kind of star that nature seems to make in great numbers, because small stars are easy to build and hard to kill. If you could put Proxima beside the sun, not in a diagram, but really beside it, like two balls hanging in space, the sun would dominate your eye immediately. Proxima would look modest, almost like the universe's quiet afterthought. And here is the funny thing. It is the closest star beyond our sun. Yet you cannot simply walk outside and see it with your naked eye. That should bother us a little, in a useful way. The nearest star is invisible to unaided human vision, not because it is hiding, not because dust has covered it, but because it is simply too faint in visible light. That already teaches us one of the first lessons of astronomy. The sky does not show us distance directly. It shows us brightness. And brightness is a trickier thing than people think. A star can look impressive because it is enormous and luminous, even if it is very far away. Another star can sit practically next door by cosmic standards, and still remain invisible to the eye. So Proxima becomes famous only when measurement replaces appearance. When we stop asking, what looks bright, and begin asking, what moves against the background? What has a measurable parallax? what kind of spectrum it gives, what its motion tells us. That is a very human correction. The eye says one thing, the instrument says another, and then the mind has to decide which one deserves trust. For most of history, stars were simply lights, fixed points that helped with seasons, navigation, stories, and fear. Then, slowly, after a great deal of wrong guessing and careful measuring, we learned that stars are suns. But even that sentence needs correction, because once people hear stars are suns, they imagine the sun everywhere. Yellow, stable, familiar, generous enough for life. Proxima reminds us not to do that. The sun is not the standard shape of every star. It is only one example. The galaxy is full of red dwarfs, not because they are spectacular, but because they are common, efficient, and persistent. They burn slowly. They last for immense spans of time, and they make up a huge part of the stellar population that our eyes barely notice. But now comes the dangerous mistake, and I want to be careful with it. Small does not mean gentle. We borrow that idea from everyday life. A small candle feels safer than a bonfire. A small wave feels safer than a storm surge. A small machine feels less dangerous than a roaring engine. But a star is not a household object, and Proxima does not have to obey our emotional categories. A red dwarf can be faint in visible light, and still behave violently in ways that matter very much to anything nearby. Think of a coal that looks dull from across the room. You might not call it bright, but if your hand is close enough, brightness is not the question anymore. The question is what that coal is doing to you at that distance. That is the uncomfortable part of Proxima. It is magnetically active. Inside and around the star, plasma is moving, twisting, carrying electric currents, dragging magnetic fields into stressed shapes. And when magnetic fields suddenly rearrange, energy gets released. Not like a polite lamp turning brighter, but like a snapped rubber band made of magnetic field and radiation. A flare is not merely a flash that looks dramatic in a telescope image. It can mean ultraviolet light rising, X-rays surging, charged particles being hurled outward. Around our own sun, solar storms can matter to satellites, radio signals, power systems, and astronauts outside the thick protection of Earth. But Earth has some advantages: distance, atmosphere, magnetic shielding. A planet close to Proxima may not get that comfortable arrangement. And here the simple dream begins to crack. Because Proxima is dim, a planet that wants enough warmth must orbit close to it. That sounds reasonable at first. Move closer to the small fire if you want heat. But moving closer also means living closer to the fire's outbursts, closer to radiation, closer to tidal forces, closer to whatever the star does, again and again over millions and billions of years. So the same orbit that may put a planet in the right temperature range may also put that planet in the line of punishment. That is why the phrase habitable zone must be handled gently. It is not a certificate. It is not a promise of oceans. It is not a little green stamp that says life can live here. It only says that under certain assumptions, the temperature might allow liquid water. Everything important still has to be earned. So I would not say Proxima makes life impossible. That would be too quick. And I would not say a planet near Proxima is safe just because it sits in a nice-looking orbital zone. That would be too easy. The honest answer is more demanding. Does the planet have an atmosphere? If it has one, how thick is it? What is it made of? Has it been stripped by stellar activity over a long time? Does the planet have a magnetic field? Is that magnetic field strong enough? How often does the star flare? How much high-energy radiation reaches the surface? Does the atmosphere recover? Or does it slowly leak into space, like air escaping from a punctured room? These are not decorative questions added after the interesting part. They are the interesting part. This is why Proxima is scientifically valuable. Not because it gives us a clean fantasy, but because it refuses to give us one. It is close enough to tempt us, and difficult enough to discipline us. The imagination wants to rush ahead. It wants a red sky, a rocky horizon, maybe an ocean, maybe some form of life clinging under a strange sun. There is nothing wrong with imagination, provided it agrees to be checked. In science, imagination is not the enemy. Impatience is the enemy. First, understand the star, then the orbit, then the atmosphere, then the surface conditions, and only after that should we begin speaking seriously about life. So, when I think about Proxima, I do not think first of a destination. I think of a test of our instruments, a test of our patience, and most of all, a test of our habit of turning every nearby planet into a story too quickly. Proxima is small, yes, but small is not the same as simple. It is faint, yes, but faint is not the same as harmless. It is common, yes, but common is not the same as boring. It teaches us to separate appearance from measurement, hope from evidence, and possibility from proof. And that is why the next question becomes sharper. If there is a world near this little violent star, can it keep its air? Can it keep its surface protected? Can it remain stable long enough for anything delicate to happen? That question is much stronger than asking whether another Earth is waiting nearby, because it does not flatter us. It makes us do the physics first. Now we can finally talk about the planet, and I want to slow down right here, because this is the exact place where the human mind begins to cheat a little. You hear the words nearest star, and then you hear planet, and almost without permission, your imagination starts building a world. It gives that world a surface, a horizon, maybe a red sky, maybe some cold ocean reflecting a small angry star. I understand that reaction. I would probably do the same thing. But physics is useful exactly because it interrupts us at moments like this. It says, wait. Do not turn a measurement into a dream too quickly. A planet is not a promise. It is a physical system. It has mass, orbit, heat, radiation, atmosphere, history. And every one of those words can ruin the picture if we are careless. The planet is Proxima Centauri b, and yes, it is the reason Proxima feels so tempting. If the nearest star had no known planet around it, the story would still matter, but it would feel more like a problem in distance and engineering. How fast can we go? How much energy would it take? How long would a signal need to come back? But once a planet appears there, something changes in the human chest. Distance becomes possibility, and possibility becomes almost emotional. That is why we have to be even more disciplined. The more exciting the object is, the more slowly we should handle the evidence. Proxima b is often described as a rocky world, roughly in the Earth mass neighborhood. That matters, because a rocky planet can have a surface, and a surface changes the kind of question we are allowed to ask. A gas giant does not invite the same imagination. You do not stand on Jupiter in the ordinary sense. You sink into pressure, gas, storms, and finally physics that is no longer friendly to ordinary bodies. But a rocky planet, even a harsh one, lets us ask about ground, minerals, weather, maybe water, maybe chemistry that stays in one place long enough to become interesting. Still, here is the trap. Earth-size does not mean Earth-like. I would almost write that on a card and hold it up every time someone says habitable planet. Similar mass is not a blue sky. It is not an ocean. It is not breathable air. It is not a morning breeze or rain or soil under your shoes. It only says, this object is small enough and solid enough for the question to begin, not for the answer to be claimed. Then comes the famous phrase, habitable zone. That phrase is powerful, almost too powerful, because it sounds like a label you might put on a safe place, as if the universe has drawn a green ring around a star and written, life may enter here. But that is not what the phrase means. A habitable zone is mainly about energy, about whether the amount of starlight could allow liquid water on a planet's surface, if the other conditions cooperate. And that little word "if" is carrying a very heavy box. If there is an atmosphere, if the pressure is right, if the greenhouse effect is not too weak or too strong, if the star has not stripped the planet bare, if water was there in the first place, if it survived long enough to matter. So when you hear habitable zone, do not hear home. Hear a question with many locks on it. And Proxima makes those locks difficult almost immediately. Proxima is a red dwarf. Small, faint, much dimmer than the Sun. So for a planet to receive enough warmth, it has to orbit very close. That is the bargain. You move close enough to get heat, but now you are close enough for the star's behavior to matter in a very serious way. Proxima b goes around its star in roughly 11 Earth days. Stop there for a moment. 11 days. That means a year on that planet is shorter than 2 weeks here. Tear less than half a month off your calendar. And that is a full trip around the star. That is not an Earth-like rhythm. Not spring becoming summer. Not a slow year of seasons. It is tight, fast, close, gravitationally serious. And when a planet orbits that close, the next thing I would ask is simple. How does it spin? Because gravity is not just a force pulling from the center like a neat diagram in a textbook. The near side of the planet feels the star a little differently than the far side. And over long stretches of time, that difference can matter. It can raise tides, dissipate energy, and slowly change the rotation. We know a familiar version of this from the moon. The moon keeps the same face toward Earth, not because it is posing for us, but because gravity had time to do its quiet work. Proxima b may have been shaped by a similar kind of patience, except the partner is not Earth. It is a small, active star. If Proxima b is tidally locked, then the planet becomes very strange by our standards. One side may face the star all the time, always receiving light, always under that red dwarf glare. The other side may never see the star at all, sitting in a darkness that is not night in the way we understand night. There may be no ordinary sunrise, no ordinary sunset, no day passing naturally into evening. And I do not say that to make it sound dramatic. This is not fantasy decoration. It is what orbital mechanics can do when a world is very close to its star. If life existed there, and that is a very large if, it would not be adapting to our gentle rhythm of morning and night. It might be adapting to permanence. Permanent light on one side, permanent dark on the other, and maybe some boundary between them where the conditions are less punishing. People sometimes call that boundary a twilight zone, and I understand why the phrase is attractive. It sounds cinematic, as if there might be a thin ring around the planet where the star hangs forever near the horizon. But again, we should be careful not to let the phrase become a painting before it becomes physics. What matters is whether heat can move. If the planet has a thick enough atmosphere, winds may carry energy from the bright side to the dark side. That could soften the extremes, keeping the day side from becoming too hot, and the night side from becoming a frozen trap. But if the atmosphere is thin, or gone, then the contrast could become brutal. One side dry and exposed, the other side frozen, the middle region fragile and uncertain. So the atmosphere is not decoration. It is the machine that decides whether the surface has any chance of being gentle. On Earth, we often forget how much work the atmosphere is doing because it is always around us. It is easy to treat air as emptiness because we walk through it, breathe it, ignore it. But physically, it is machinery. It moves heat, carries water, sets pressure, shields the surface, and keeps night from becoming instant catastrophe. Remove Earth's atmosphere, and Earth is no longer the world. You mean when you say home? The oceans would not behave the same way. The temperature would not behave the same way. Radiation would not behave the same way. So when we ask whether Proxima b could be habitable, we are not really asking whether it sits at the right distance. We are asking whether it kept the right kind of atmosphere through billions of years of trouble. And Proxima gives plenty of trouble. It can flare. That means bursts of high-energy radiation. And radiation is not gentle with molecules or atmospheres. Ultraviolet light can break molecules apart. Charged particles can interact with the upper atmosphere. And over long times, gases may escape into space. Now, I do not want to make the opposite mistake either. We should not say, flares, therefore dead planet. That is too easy, too confident, and probably too lazy. The real question is history. Did the planet begin with a thick atmosphere? Did it have water early? Did the star behave more violently when it was young? Did the planet have a magnetic field? Did volcanoes replace some lost gases? Did water hide somewhere long enough to survive? Habitability is not just a place in an orbit. It is a story that happened over time. That is the part I think people often miss. A planet can be in the right zone today and still have lost the important battle long ago. It can receive the right amount of light now, but if its atmosphere was stripped away billions of years earlier, then today's sunlight arrives too late to help very much. Or maybe the opposite is true. Maybe Proxima b kept enough air. Maybe heat circulates. Maybe water survived in protected places. Maybe chemistry found a small, stable niche. We do not know enough to celebrate, and we do not know enough to dismiss it completely. That is not weakness. That is the honest shape of the evidence. So Proxima b is powerful not because it gives us an easy answer, but because it teaches us how careful the question must be. It is near. But near does not mean reachable. It is rocky. But rocky does not mean Earth-like. It is in the habitable zone. But that does not mean inhabited. It may have conditions where water could exist. But possible water is not a living ocean. The planet pulls the imagination forward, and then the measurements pull it back. I like that tension, because that is where science is most alive. Not in pretending we know everything, and not in refusing to wonder, but in holding wonder and discipline in the same hand. So when we picture Proxima b, let us not picture a second Earth waiting politely next door. That picture is too easy, and too human. Picture instead a small rocky planet close to a small restless star, caught between heat, gravity, radiation, atmosphere, and time. Maybe it is barren. Maybe it is strange. Maybe it kept something precious. Maybe it lost it before any telescope could ever tell us. That uncertainty is not disappointing. It is the real object we are studying. Before Proxima b can be a destination, it has to become a problem. We understand. And before we send our dreams toward it, we should admit one simple thing. The nearest possible world beyond our solar system may be much harder, much stranger, and much less Earth-like than the first picture our imagination wants to build. Now let us come back to the harder sentence, because this is the part where the imagination usually runs faster than the machine. Suppose Proxima b really is interesting. Suppose it has an atmosphere. Suppose somewhere on that dark red world, there is a place where liquid water can exist for a while. Good. That would be wonderful. But I want to stop right there. Not because the dream is foolish, but because a dream becomes useful only when it begins paying attention to the bill. And the bill here is not small. It is not a matter of buying a better engine next year. It is the difference between traveling inside the solar system and trying to cross the empty space between stars. Proxima Centauri is about 4.24 light-years away, which sounds almost polite when you say it quickly. 4.24. Small number. Friendly number. But that is the trick. A light year is not a year. It is the distance light travels in a year. So we are talking about roughly 40 trillion kilometers, a number so large that ordinary comparisons begin to lie. You can compare it to airplanes, oceans, highways, walking, anything you like. But after a while the comparison becomes decorative. It no longer helps the mind feel the scale. So use time instead. Light itself takes more than 4 years to get there. A radio message takes more than 4 years, and a reply takes more than 4 years to come back. Already, before any rocket is built, Proxima has removed conversation from the mission. Now ask a simple question. How fast would we have to go if we wanted this journey to matter inside a human lifetime? Not 10% better than today, not a little faster than a Voyager probe, but a serious fraction of the speed of light. Let us say 10%, just to have something clean in the mind. 10% of light speed already feels almost absurd. But even then, if we ignore acceleration and braking, the trip still takes decades. And notice what I just did. I smuggled in the easiest version of the problem. I said ignore acceleration and ignore braking. That is not a small footnote. That is where much of the monster is hiding. Because going fast is only half the sentence. Stopping is the other half. If a spacecraft screams through the Proxima system at some large fraction of light speed, it has not arrived in the way people usually imagine. It has passed by, perhaps beautifully, perhaps scientifically, but still passed by. A flyby can be magnificent. I do not want to insult it. A tiny probe crossing 4 light years and returning even a small amount of data would be one of the sharpest moments in human exploration. But a flyby is not orbit. It is not landing. It is not a settlement. It is a camera blink at another star. Very precious, but very different from staying there. Here is where energy enters, and energy is not impressed by our enthusiasm. In ordinary mechanics, speed becomes expensive very quickly. Double the speed, and you do not merely double the energy. You need 4 times as much. Increase the speed by 10, and the energy rises by about 100. That little square in the energy law is the universe putting a price tag on impatience. And then mass comes along and quietly makes everything worse. A small chip is one thing. A probe with instruments is another. A human vehicle is another universe of difficulty. Every kilogram has to be accelerated. Every shield, every cable, every spare part, every drop of water. The machine is not just carrying equipment. It is carrying consequences. Fuel makes the trap more interesting, and also more cruel. If the spacecraft carries its own propellant, then the propellant has mass, and that mass must be pushed too. Then you need more propellant to push the propellant, and more structure to hold it, and more energy to move that structure. You can feel the problem beginning to eat its own solution. This is why chemical rockets are extraordinary near planets, and still not a clean answer for reaching another star inside a human lifetime. That is not a criticism of rockets. It is a statement about scale. The tool that lifts us from Earth is not automatically the tool that carries us between suns. So, people imagine other methods. Light sails, giant beams, nuclear propulsion, fusion engines, antimatter ideas. Some careful, some very speculative. The common thought is reasonable. Stop carrying the whole engine inside the spacecraft. A laser sail does something clever. It leaves much of the energy source behind, and pushes a very light craft with a beam from far away. For a tiny probe, that idea has a kind of brutal elegance. Make the craft small. Push it hard. Let it fly. But then the next question comes immediately. How do you aim the beam across such distances? How does the sail survive the acceleration? How does the probe communicate back? And when it reaches Proxima, what exactly does it do, besides rush through? Now separate that from a human mission, because a human mission is not a bigger version of a little probe. That is an easy mistake, but it is a serious one. A human spacecraft is not just an instrument with people added. It is a room, a pantry, a hospital, a workshop, a shelter, a little piece of earth sealed inside a moving machine. It needs air, water, food, repairs, medicine, shielding, and some way for human minds to remain human over a very long time. That last part is not poetry. It is engineering too. A machine can fail because a bearing breaks. A crewed mission can fail because people are biological, social, tired, frightened, and far from help. Radiation adds another layer. Outside Earth's magnetic field, space is not empty in the friendly sense. Charged particles and cosmic rays become part of the environment, not background decoration. Shielding can help, but shielding has mass. More shielding means more mass. More mass means more energy. And more energy means the propulsion problem grows again. This is what I mean by coupled problems. The universe rarely hands you one clean obstacle at a time. It ties them together. You solve one, and the other one becomes heavier. Even dust becomes strange at these speeds. And that is a good example because dust sounds harmless. A little grain drifting between stars. Almost nothing. Almost invisible. But if the ship is moving at 10% of light speed, that almost nothing is no longer gentle. The danger is not that space is crowded like a storm of rocks. It is that speed changes the meaning of collision. A tiny particle can hit with serious energy because the spacecraft is moving so fast through the medium. So the ship needs protection from things that barely sound like things. It needs armor against almost nothing. That sentence sounds absurd, but at interstellar speed, it is simply physics. And communication. Communication is where the loneliness becomes measurable. If something goes wrong near Proxima, Earth hears about it more than 4 years later. If Earth sends instructions, those instructions arrive more than 4 years after that. So the mission cannot depend on real-time help. It must diagnose, choose, repair, and continue on its own. At that distance, Earth is not mission control in the ordinary sense. Earth becomes memory, preparation, and a very delayed voice in the dark. So when I say Proxima is not a destination yet, I am not trying to make the universe smaller or the dream poorer. I am trying to make the dream honest enough to survive contact with physics. Proxima gives us a list of prices: distance, time, speed, energy, braking, fuel, dust, radiation, biology, autonomy. Any one of these would be hard. Together they mark the edge of what our civilization can presently do. But that is not failure. That is the first useful measurement. Once a dream has numbers attached to it, we can stop waving our hands and start asking better questions. What must become lighter? What must become faster? What must become autonomous? What must become safe enough to trust across 4 years of silence? Proxima Centauri is not waiting just outside the door. It is teaching us how far the door really is. And for now, that is enough to make it important, not as a place we can casually go, but as the nearest measurement of the price of the stars. So what do we do with Proxima Centauri, after we have looked at it honestly? I think the first thing is this: we should not lie in either direction. We should not say, "There it is, the next home of mankind," as if a star 4 light-years away is just a difficult airport connection. But we also should not shrug and say, "Too far, forget it." That is not how science thinks. Science does not meet a hard distance and immediately turn it into a myth or a defeat. It does something much more useful. It asks, What exactly is hard here? Is the hard part speed, energy, time, biology, communication, or the simple fact that space-time does not care how impatient we are? That question may sound less exciting than saying, "We are going to the stars." But it is actually the beginning of any serious way to get there. Proxima is strange because it is both close and impossible, and that combination bothers the mind. If it were a galaxy billions of light years away, we could leave it in the category of wonder. Beautiful, unreachable, something for telescopes and imagination. But Proxima is not that kind of object. It is the nearest star beyond the sun. That word nearest feels friendly, almost domestic. It sounds like the next house down the road, the next island beyond the fog, the next small step after Mars and the outer planets. Then you put the number beside it, and the friendliness disappears. 4.2 light years is not a poetic distance. It is a physical demand. It asks a machine to cross tens of trillions of kilometers. Not in a story, but in actual time, with actual energy, actual materials, and actual failure modes waiting in the dark. That is why I do not like treating Proxima as a destination yet. A destination is something you can plan around. You may not go tomorrow, but the word implies a route, an arrival, a way to stop, a reason to unpack. Proxima does not give us that yet. What it gives us is a measurement. It measures our rockets, and the result is uncomfortable. It measures our energy systems, and reminds us that speed is not free. It measures our engineering imagination, because a spacecraft going very fast through interstellar space cannot be treated like a little boat on calm water. Even dust stops being innocent at those speeds. A tiny grain is not just a tiny grain anymore. It becomes an event, a collision with real consequences. That is the kind of detail that a romantic sentence usually leaves out. But physics never leaves it out, and then there is the delay, which sounds simple until you feel what it means. A probe near Proxima cannot phone home and ask, "What should I do now?" Earth would be years away by signal, not minutes, not hours. So the machine has to carry a kind of independence inside it. It has to notice, choose, adjust, protect itself, and still remember why it was sent. That is a very different kind of exploration from driving a rover on Mars, where patience is hard but still humanly imaginable. Interstellar distance changes the personality of the mission. It makes the spacecraft less like a tool in your hand, and more like a messenger you release into a silence that you cannot control. Now, if we put human beings into that picture, the problem becomes even more severe. I do not mean merely heavier, although it becomes heavier immediately. I mean stranger, because a human body is not equipment in the simple sense. It is warm chemistry, bone, water, bacteria, memory, fear, habits, and needs that do not disappear just because the mission is noble. You must carry air, food, water, medicine, shielding, gravity, or some substitute for it. But you also have to carry something harder to draw on an engineering diagram. You have to carry meaning. That may sound soft, but imagine decades inside a machine, with no Earth outside the window, no rescue coming quickly, no ordinary horizon. Meaning is not decoration there. It is part of survival, So perhaps the first real step will not look heroic in the old way. It may not be a person stepping down a ladder, or a flag bending in weak gravity. It may be something smaller, almost disappointingly small at first glance. A sail, a chip, a camera, a transmitter, pushed by light toward a red star. It may not stop when it gets there. That is important. It may only pass through. A few minutes, perhaps a few hours of useful encounter after decades of waiting. That sounds modest, only if we forget what is being attempted. A human-made object crossing the first true interstellar distance and sending back measurements from another star system. That is not modest. It is quiet. Yes. It is not the fantasy version. Yes. But it would be one of the cleanest signs that our intelligence had finally touched another star with an instrument. I think that is the mature way to look at Proxima. Not as a promised second Earth, and not as a wall, but as the first ruler laid across the dark. One end of that ruler sits here, with our machines, our equations, our limited engines, our impatient imagination. The other end sits at a faint red star, close enough to tempt us, far enough to correct us. And correction is not the enemy of wonder. It is the thing that makes wonder honest. Nearest does not mean close. Small does not mean gentle. Promising does not mean habitable. Rocky does not mean earth. And fly by does not mean arrival. These are not disappointments. They are the removal of bad pictures. Once the bad pictures are gone, the real problem appears. And the real problem is always more useful than the fantasy. So I would end the thought this way. Proxima Centauri does not shrink humanity. It clarifies us. It shows that we are clever enough to see the nearest star, measure planets around other suns, send machines beyond the outer planets, and calculate journeys that our hardware cannot yet make. That is not failure. That is a young civilization beginning to understand the size of the lesson. We are not ready to call Proxima a destination. Not honestly. But we are ready to ask what would have to become true before that word could be used without pretending. And that is already a serious step, because every real reach begins before the reach itself. It begins when you measure the distance without flinching, admit what is missing, and then start building from the truth. The stars do not become smaller when we understand them. We become more honest. And maybe, slowly, more capable.